Hey guys, hi, welcome to GeeklyEDU. I hope all of you are doing fine and excellent. And today we are going to talk about how to balance nuclear reactions. So I hope you are well familiar with nuclear reactions. You know about alpha, beta, gamma, and other kinds of radiations which we already discussed in the last few videos, right? If you haven't, just go and check them out, okay? And today what we're going to do is we are going to try to balance the nuclear reactions. So let's hit it, right? Okay, so I want you to push the pause button here and try to do it yourself first, and then we'll discuss about it. Radium-228 decays by alpha emission. You already know what's an alpha emission. What new nucleotide forms in this reaction? Well, so they already have given you what is an alpha reaction, right? So alpha is doubly charged helium particle, right? So that's radium, and this is X, which we don't know, which we have to find out, and we already have alpha. So let's first try to attack the atomic mass. So 228 minus 4. Why? Because that is the charge, right? So we find out that the final mass of the X. So let's say mass of X should be around 2 to 4, right? Now we have to talk about atomic number, right? So once again, remember, alpha particle, that is He2 plus, has the atomic number of 2, right? So we have 88 minus whatever is the whatever do we want? We want to subtract 2, right? So that comes about to 86. So we are looking for an element that has a mass of 224 and 86, right? And this comes out to be the radon, right? So this is our answer. It's very simple if you see, right? Now that you have tried already the first question, I hope the second question would be very for you. But the only catch is I have changed the emission here, so it's a beta emission. Go ahead, push the pause and try to do it. I hope you'd have done this, and well, it's pretty simple, right? So let's say mass of X must be 14, which is the mass of the given carbon, minus whatever is the mass of this beta. Now beta has, as you can see clearly here, 0 mass, right? So the mass of X has to be 14. Now let's talk about the atomic number of this little nuclei X. Now once again there's minus 1, right? So we already know for carbon that is 6. So let's say 6 minus minus 1. Now minus minus makes plus. So that means we are looking for the atomic number 7. So this X has a mass number 14 and an atomic number of 7. And we know we are talking about the element nitrogen, right? So once again, pretty simple, okay? One last question, and here also we have the same thing. Again, the only change that you'll find here is in the emission. So I hope this should be a piece of cake for you, because now you have already solved a lot, right? So push the pause and then let's go for it. Okay, so once again, mass of X, right? So we have 18, that's the mass of fluorine, and I have to subtract the mass of this, and here the subtraction needs to be done is 0, because that's the mass of this positron, right? So that means the mass of X is same. Now let's go for the atomic number. Atomic number of X, once again, 9 minus 1, that is 8. So you're looking for an element which has a mass of 18 and the atomic number 8. Now you know the atomic number 8 is oxygen, right? So that's your answer. So we have solved 3 very simple problems, and I am very sure you are ready to be challenged with new, right? So actinium-227 decays and emits 5 alpha particles and 3 beta particles in 8 steps. What is the final product? So 5 alpha, 3 beta. So this is sort of homework, and I want you to do it. And don't worry, I'll come up with a solution for this in our next video, where we are going to talk about how does a nuclear reactor actually work. So I will talk about this problem there, but please try to solve this on your own, and we'll meet very soon.
We hope you like this video. Press subscribe, thumbs up, and stay geekly.